Japan's location on the Ring of Fire has made it one of the most seismically active countries in the world, but tsunamis are hard to predict, even using modern technology. So how is Japan working to prevent the next disaster? Japan has been formally studying tsunamis and developing countermeasures since the 1896 Sanriku earthquake, which produced waves peaking at a then-record 125.9 feet high. The supercomputer Fugaku. This mammoth of a computer is powered by 158,976 individual CPUs, each running 48 high-speed multi-threaded cores. It is currently the fastest supercomputer in the world. By analyzing data from past tsunami events, the supercomputer is able to simulate 20,000 different potential post-tsunami scenarios. Fugaku is able to simulate flooding scenarios in various regions throughout Japan by combining AI and a deep learning algorithm. This enables the government to plan and build protective structures for coastal regions more effectively. Following the 2011 tsunami, it allocated upwards of $17 billion for the construction of new seawalls to replace those destroyed. Dubbed the Great Wall of Japan, this construction project spans over 245 miles in length at an average height of 42 feet. They propose a new type of seawall, the recurved seawall. The main difference between this and a regular seawall is its concave surface facing the sea. In small-scale tests, engineers have found that this design significantly decreases the wave overtopping rate. It also increases the force generated by the breaking waves. To address this weakness, engineers have proposed these seawalls to be constructed using reinforced steel and high-grade concrete, thus improving their structural rigidity. A seawall has already been erected with this design. The flaring-shaped seawall, built along the Osaka port in Kurahashi-cho. Engineers have also been working on new ways to construct traditionally designed seawalls. The main problem with the construction of old seawalls is the main material used, concrete. Due to its brittleness, concrete tends to not only break, but also increases the force of a wave, worsening its potential effects when it meets land. To remedy this, Japanese engineers have adopted a different design philosophy for their seawalls. Newer seawalls are laced with steel hoops, which encourage movement during a tsunami event, provide ductility to these structures, and prevent large chunks of it from becoming deadly debris in the event of a break. Cambridge professor Dr. Gopal Matabushi has recommended a different design philosophy for building construction moving forward. Matabushi advises that buildings should be designed and built with the intention of allowing water from tsunamis or floods to flow through easier. One way of achieving this would be by featuring an open design on the first floor by installing larger doorways and windows. Some buildings could even feature designs with the entire ground floor open by raising the structure above ground on stilt-like foundations. The end goal of building buildings in this way would be to protect foundations and make reconstruction efforts easier.